Oh, yes, I'm sorry.
Hi, Madeline Pipes, One Florida Foundation. I'd like to get back to those numbers that you were talking about regarding the phosphorus coming into your treatment facility. Can you talk to me a little bit about where that's coming from and why?
It's coming from a wastewater treatment plant.
Okay, but it's just the sheer number of, you're talking it's just the population problem, right? And then you go into your treatment center, and then where does it go from there? I'm sorry, I'm from South Florida, so I'm trying to figure out what it is you're talking about.
So our system is, our wetland system is hooked to an advanced wastewater treatment facility, so it's tertiary treated. They produce pretty good quality nitrogen and phosphorus. It's reclaimed water. If it's not sent to our wetlands, it's also sent back for irrigation on people's yards, and it goes to the Orlando International Airport and irrigates all of the landscaping there. But our wetlands is created to polish out those excess nutrients if we can't dispose of it through public access reuse.
What do you use to polish?
The created wetland filter marshes, basically. So a lot of the cattail marshes that you've heard about.
Is it all natural, or are you using anything additive?
It's created. It's all natural vegetation and everything, but it's a man-made wetland system.
Sure, I was just asking, I know that there are various, things that people are adding, structural things that have like I can't think of the term, but there's the little balls and things that people are adding extra, so I was just wondering if there's any of that.
No.
No? Okay, thank you.
If you go to our YouTube channel, search Google or search YouTube for United Watercolors FL. Mark is one of our previous speakers, and he did it. His presentation was on the website.
Okay, great, thank you.
Would a good analogy be the Wakotahachie or Green Cay wetlands in
Yes.
Boynton Beach? I don't know if you're aware of those wetlands. Yeah.
Okay, thank you.
Yeah, the claim to fame for the Orlando project is we've always called ourselves the world's first large-scale constructed wetland treatment system. It was created back in 1985 and went online in 1987. And we've been receiving anywhere from 12 up to 20 million gallons a day of reclaimed water.
All right, thank you.
And I also want to mention, too, on the bird thing, going back to that, we also have had issues. And I mean, we've been looking at phosphorus and nitrogen for quite a while. And one of the great concerns we had was with the number of coots when we'd see them show up in the wintertime. And we had these beautiful southern naiad, not just submerged aquatic vegetation beds. And lo and behold, by the end of the winter, they're gone because the coots have eaten it all down. And we're monitoring water every day in these, what's flowing out of these cells. And we noticed that ammonia nitrogen, really peaked during the time that the coots showed up, but not so much phosphorus. Where we have had phosphorus issues have been with black vultures and turkey vultures, and also around the rookeries and coming off the tree islands. So.
Anyone else? Yes.
This question is for Peter. Peter, the Comprehensive Hercules Protection Act deals mainly with phosphorus. They consider phosphorus, that's the main thing. Like, for instance, the developers up in Osceola County, when they're preparing their water fund rules or their retention pond stuff, they focus on phosphorus. They treat the phosphorus. I believe you mentioned something about, is nitrogen going to be a component, a regulatory component eventually, for what Okeechobee is supposed to treat, especially considering the estuaries that the water goes to?
It's a pretty complex question, and I'll try to be short as I can with it. But I think Casey mentioned earlier in his talk the complication about identifying what is the limiting nutrient, whether it's nitrogen or phosphorus. One thing that's very important for everyone to keep in mind is that these aquatic systems in the state of Florida are so impacted by humans that we are changing the fundamental biogeochemistry in terms of what is the limiting nutrient. For example, we believe the Indian River Lagoon in Central Florida, East Central Florida, is so saturated with nitrogen, we're actually driving it to phosphorus limitation in a lot of areas, and that's very much unheard of and marine systems. Alternatively, we may have such bioavailable phosphorus, ironically, in some of our freshwater systems that we may be driving it to either limitation by nitrogen or co-limitation. And I'll give you an example of that. Carl Havens and Tom Fraser have recently come out with a publication and a nice IFAS article on the concept that we really can't live with this or work in the future with this dogma that we only need to address phosphorus in Florida's freshwater systems. In fact, Carl has come out and said in this IFAS review that we need to look at both nitrogen and phosphorus in Lake Okeechobee and in Florida's freshwater systems, taken by a case-by-case basis. For example, if we've done a good job at removing nitrogen in some freshwater system, but we have wastewater coming in, it's going to have a lot of phosphorus, and it's probably going to drive that freshwater system to nitrogen limitations. So as Casey said earlier, you know, we've got to pay attention to nitrogen as well as phosphorus in these systems.
I have a question. Peter, these blue-green algae that are causing problem in the coastal areas, and of course you and I discussed last night about Lake Okeechobee's issues, but a lot of these they're nitrogen fixers from atmospheric nitrogen. So even though if we limit our inputs up in the basins, how do we, you know, if we get this nitrogen phosphorus imbalance too broad, then you know, we reach that point of diminishing returns. How do we address that?
Again, it's another, and the thing we have to be careful with blue-green algae is that they don't act like algae. We call them blue-green bacteria because these are the first organisms that evolved on the planet. They can do anything. So when I say anything, as you said, they can fix nitrogen if they need to, but that's how they evolved to in oligotrophic systems. But when you saturate a system with ammonium, many of them are going to preferentially take up bioavailable nitrogen rather than fix it. So in the past, well, we said we only need to concern ourselves with phosphorus in freshwater systems because if we stop the phosphorus, then they wouldn't fix nitrogen because their N to P ratios would be so high that it wouldn't behoove them to fix nitrogen. So we are in a scenario here where what we're doing by artificially over-enriching these systems is we are selecting for these primordial organisms that have adaptive capabilities to subvert our best intentions to manage nutrients. They'll do whatever they got to do to preferentially take up nutrients. For example, some of these macroalgae that are real deep, dark red seaweeds, we cultured them at Harbor Branch going back to the 80s, looking at mitigation strategies for taking up nutrients in wastewaters, not unlike these constructed wastewater systems. But they will take up ammonium and phosphorus and just store it like crazy when it's there. So, you know, these organisms can survive, you know, if they can get a pulse from one rainstorm, they may take up enough nitrogen and phosphorus to bloom for weeks or a month after that. So we're dealing with very adaptable organisms that can really subvert, you know, I think our best intentions and abilities to mitigate nutrients in the environment. So these are very complicated issues you brought up. And so to answer your question, I hope I didn't go too far with it without answering it, but we think in the St. Lucie estuary that guacamole thick microcystis is probably not fixing nitrogen. It's probably preferentially taking up ammonium, and our evidence for that is in those N15 values in those microcystis, that if they were fixing nitrogen, that del N15 value would be around 0. But because it's plus 8.6, and those are very similar values that we see in springs and places where there's septic tank effluent, and that is they're preferentially taking up ammonium rather than fixing nitrogen. So that is our strong evidence for that.
Okay. Yeah, Pete.
Would you comment on the climate change impacts? A few years ago, the Upper Caloosahatchee lost all of its Carolina clams. We got over the thermal limit for them. And I would guess that many of our patterns of bird migration, everything else, is also being impacted by changes of temperature. How is that being factored into the plans and the programs that we're dealing with?
I think every agency has been pretty good about having contingencies for climate change. I think if you talk to our representatives from the districts here, they know that there's a schedule for conservative estimates of sea level rise. It's going to affect saltwater intrusion. All these systems are going to be confounded, our efforts to mitigate problems by sea level rise and climate change. But in the shorter term, what we know is that when you take a water body and you over enrich it with nutrients and you get algal blooms, you're creating what we call a black body system, where it's actually going to trap and attract more heat and absorb it rather than reflect it. So I think a lot of the concern for climate change is absolutely confounded by the things we're doing right now. I've flown out of Melbourne Airport, and you take off over the Indian River Lagoon and then go over into the Atlantic Ocean and veer north or south, depending where you're going. But I'm just absolutely amazed at how black the Indian River Lagoon looks from a light absorbance standpoint. I mean, it's sucking down heat. So to your point, these algal bloom issues are, we know these systems are saturated with nutrients, but by the way, when you increase the temperature, you increase the photosynthetic rate. So the metabolism of these organisms are maxed out. What we saw this spring with the brown tide bloom was that it happened in the wintertime, which really amazed us. I mean, why are we having a big algal bloom in the wintertime? Well, we probably had enough bioavailable nutrients. But that bloom, we believe, started peaking out in the spring when we started getting maximum radiance in just a couple degrees temperature increase. And what we saw is by the end of the March, that bloom crashed. And those of us that have cultured phytoplankton in a laboratory, and I've done plenty of that for growing other organisms, we know that when you max out the heat, they go into photosynthetic, maximum growth, and then all of a sudden they crash out and bacteria take over. So one of the paradigms I think the agencies agree with was that the bloom was fed with a lot of rainfall from the El Nino event this winter, a lot of nutrients that came with it. Amazingly bloomed pretty heavily in the wintertime, but reached its maximum biomass with irradiance and temperature reaching the peak point. And at that point it maxed out, it died, and the bacteria took over, sucked the oxygen out of the water, and then we had the fish kill. So absolutely temperature is an important physical factor here. But again, we're making changes to our coastal environments that are probably preceding and confounding any issue with climate change.
Anyone? Any more questions? Come on, guys.
So the dark water, can you explain some of the mechanisms that are affected by that as far as the food web and different populations of shellfish and fish?
Well, I guess the point is, from a standpoint of physics, that when you have a more transparent body of water, that there's a lot of reflectance off the surface, but then the absorbance, the light will make it through the water body and be sucked up by macrophytes or bounce off the bottom. There's a lot of physics to light in the marine environment. But when you have a water body that's full of phytoplankton and a lot of turbidity, it will actually trap light and bouncing around in there, or photosynthetically, these phytoplankton are going to suck it up. So they're actually absorbing heat. And ironically, as photosynthetic organisms, they're producing oxygen in the day, but they're also kicking out CO2 at night. And that's when we get these conditions where the oxygen drops out. So we're absorbing a lot. We're plenty of bioavailable nutrients, as Ed Flips and others have said, for the lagoon. But then you add a little bit of heat, and you got enough light. And these things are in maximum growth. But there's a consequence to that because you cut off its food supply or the light goes down, we have storms for a few days, and you cut out the light they need to photosynthesize, the system goes into net respiration. And then that's when we have the CO2 and the demise of oxygen and the benthic layer in our fish kills like we saw this spring.
Anyone else? Yes.
Back down to the coots in the Everglades, and maybe somebody can enlighten me and bring me some thought here on numbers historically. You know, I saw some excitement in the numbers of a lot of them because we had nitrogen-rich water and everything's growing better, so the duck population grew better also. Can you relate that over history of time and those shoots and numbers?
Right. So, you know, we're seeing all these ducks and coots in the SDAs, and the reason is that you've got this highly productive system, and you've got all the right conditions. We're keeping the area open, so you've got all these wonderful sort of open water habitat for them, and all the food that they can eat, and it's very high quality food. Of course, the historic Everglades, at least the northern part of the Everglades, probably didn't have anywhere near those numbers of waterfowl. However, I wrote a paper with various different folks from NOAA, and included Jerry Lorenz from Audubon, and actually was one of John Ogden's last papers. I don't know if you're aware of John Ogden, but basically we looked at all the factors that are affecting birds in the coastal zone of Everglades National Park. And as part of that study, it was really just a qualitative study where we were looking at historical records, and my job was to look at the waterfowl component of it, and I was amazed at how those coastal bays, estuaries, and lakes were just chocker full of scorp and blue-winged teal and coots. I mean, you know, you can only rely on those historic accounts to some level, but consistently with different people over 10, 20, 30 years, these guys were writing in, you know, 50,000 coots, 20,000 scorp or bluebills. So, you know, it's really interesting. Whereas I think the freshwater marshes of the Everglades historically didn't have, I think they had a lot more ducks than they have now. But I think the main areas where we saw ducks historically were in those coastal estuaries, and huge numbers.
Okay, anyone else?
I could add that the reason why we think they disappeared is because we don't get enough freshwater flow. We've lost a lot of the SAV, the widgeon grass, and a lot of the invertebrates have disappeared from those ponds and lakes in the southern part of Everglades National Park. So, you know, the numbers dropped in about the 1950s and 60s as the salinity of those lakes and areas increased. I'm not sure that's the entire reason, but I think as soon as we can get fresh water flowing back down to the south and into Everglades National Park again, the better.
Ken, anyone? Okay, I'm gonna come back. There we go. It does.
Okay. Do you think possibly the demise or decline in coastal marsh areas like the Everglades, coastal region down there, is because of the lack of freshwater outflow that used to create the freshwater lens around the perimeter of the state?
Yeah, I'm not sure it's anything to do with the lens. I just don't know in that respect. That probably be for somebody else to ask. But certainly, the increase in salinity has had an effect on the food that they eat, and I think that's the major reason why these populations have collapsed. Although, having said that, for some reason, the last few years have seen really large numbers of coots in some of those bays and lakes again. So, not so much the ducks, but the coots have returned for some reason. Did you want to answer about the lens?
Dennis, that's a pretty interesting question. I know there's been some reports on, and maybe Casey can help us with this a little bit, the effect of water withdrawals on the hydraulic head and the pressure of fresh water discharging into the southern Everglades and the Biscayne Bay. There's some really interesting reports, not only of the bays, but even offshore the shelf off the Palm Beaches, of just amazing groundwater flows and discharges. In fact, the Spanish galleons that came from Cuba that were going back to Spain full of treasure would stop off the Palm Beaches because the groundwater discharging in these major flows offshore was so significant that they would stop and fill their barrels with the hydraulic flow of fresh water coming above the seawater. And they didn't want to go on land, they didn't want to get shot by Native Americans, so they would just dip the fresh water that was literally boiling off the coast of the Palm Beaches. And there's really some very, very interesting reports from Biscayne Bay about how there was significant groundwater discharge there. And we know that those groundwaters have a high amount of alkalinity, and they were probably very important in supporting that system being a calcifying system where you had more reef-type organisms, calcifying algae and such. But very interestingly, they probably brought some natural nutrient letting too that created small oases in a more oligotrophic system that were very productive, delivering fresh water, but also creating a lot of biodiversity there. A lot of that's gone, and I know that whether you're in the Everglades or whether you're in the nearshore coastal waters, we're obviously not getting the fresh water, the groundwater discharge from having adequate head pressure on land. So the long answer is there's no doubt that the coastal systems are affected by a lack of groundwater discharge.
Not a question, but just to add to that, a couple of old books that I have, I like reading old books. I can't mention a couple of them.
John has also pointed out one of those books about southern Brevard County, and in the little bay that I grew up in, which is Palm Bay proper, we had a large spring run that came into the bay, and that bay historically was known as very prolific for oyster production. And we know this because for the past 10,000 years, we know the Ais Indians inhabited the rim of that bay and actually all along the lagoon and that portion of the lagoon, and had these massive shell middens where they were really kicking it on the oysters. And we have some very interesting historical records. There was a grad student at University of Florida. When there were classic changes in climatology over time, some of these systems, they would show different strata of oysters and then clams, which I think did a little bit better in more saltier conditions, and then different strata of oysters. So these middens are really impressive from the standpoint of telling us about the fisheries in these coastal ecosystems, but also we know that some of these middens that were inland a little bit more have a very interesting, I think, paleobiology of the types of plants that were associated with them, and we know a lot about the diversity of plants with medicinal value and such from these midden areas, that some of them still exist.
Anyone else? If you have any questions up on the St. John's and the Willow work, I see that Steve Miller snuck back in. No pressure.
Still on the spring flows and the hydraulic pressure in the Florida and Biscayne aquifer. What work is being done to increase that, to replenish the aquifers, to increase that hydraulic pressure? Is there anything being studied or done?
Yeah, I guess big picture, there has been a reduction in potentiometric head in Florida in general. We have had, in general, reductions in spring flows, probably on the less than 10% range in general. You look at if you look at the big picture, that's going to be a challenge. The Florida aquifer, as you know, goes all the way up into, well, South Carolina, so through Georgia to South Carolina. So any pumping that's taking place anywhere in the southeastern region of the country is going to have some effect on the Florida aquifer, which is what most of us utilize, and then the Biscayne aquifers down separate farther south. What we've done, and probably the most intense effort in this matter, is in the greater Orlando area, the Central Florida Water Initiative, where we have looked at current demands on water use and future demands on water use, and we have concluded that there is not enough water in the aquifer to provide that extra 250 million gallons a day they're going to need in the next 20 years. There might be another 50, although that's debatable. So pretty much where we're at is, in that region in particular, we've pretty much hit the wall in terms of what you can take out of the aquifer. So what we are doing right now collectively with the South Florida District and Southwest Florida District is a unified collaborative effort to identify alternative water supplies and/or adequate conservation such that we will not further impact the aquifer. And again, the springs are the real indicator there. The Wekiwa River system, is one of the key limitations on those withdrawals. So we've set an MFL, as I mentioned before, these minimum flows and levels for the Wekiwa, and that's pretty much drawing the line, which says you really can't take any more out, we can't reduce those flows anymore, so you have to go to alternative methodology. Clearly, the least expensive option is conservation. If 50% of the water pumped out of the ground wasn't used for lawn irrigation in that region, then we'd be in pretty good shape. So if you look at what needs to be done, I think our first focus would be, let's promote more and more conservation. Let's even get into conversion of lawns to xeriscape, that sort of thing. If you could do that on a large scale, you could certainly buy yourself a lot of time. But the Central Florida Water Initiative will come out with a series of pretty detailed recommendations. I'd say within the next year and a half is probably about their timeline for that. And that'll probably be a pretty good model for what can be done elsewhere. So that's probably the number one effort that St. John's and Swift Mud and South Florida are involved in to try to deal with that issue.
Sure, go ahead.
We've been looking from Ocala National Forest at water-wise infrastructure. It seems like California's light years ahead of Florida, and we start looking at water recapturing, like the fact that we're using aquifer water to flush a toilet or to wash a car. Instead of recaptured water, reused water, we're taking this really pristine water that's great for drinking. It's really not a good system. So with the districts or support from legislation here in Florida, are we moving in that direction with, or are we still under the misconception because we get enough rain that we're still a really wet state? Where do you think we're going and what's going to be available to us for implementation?
Well, again, what I was saying was pretty much we figured out we do not have enough water resources from our standard go-to aquifer. So we will be promoting, again, conservation on every level. I will say that we're not really behind California. If you look at, they've actually had their land surface drop, 50 to 60 feet in certain areas because they have pumped the aquifer so severely in the Central Valley. So frankly, we're in a whole lot better shape than someplace like California. And granted, the main reason is we do get 50-some inches and they get 12, give or take.
I did mean technology that's available.
Right. Well, when you look at it, Tampa Bay, when they built their desal plant, that was the biggest one in this country. California did just build one, I think, in San Diego that's 50 million gallons a day instead of 25, but Florida was out there. We have a lot of desal plants. The downside with desal is it's expensive. It's got a large carbon footprint. So you don't really want to go that way, which again, I think the multitudinous ways you can deal with conservation is really going to be the best option, and we're going to be promoting that to the maximum extent possible. We also did, for example, a study on the St. Johns River to see how much water could be taken from that surface water source and used less out of the aquifer. You look at that flow, it's in the neighborhood of, I think, about 6 to 7 billion gallons a day. And we estimate you could take 150 million gallons a day without having any adverse effects. You would have to vary it geographically and seasonally and flow, but on average about 150 million gallons a day, and that mostly would be used in the Central Florida area right around Orlando. So we did a very detailed analysis on that a few years ago that was reviewed by the National Academy of Sciences to make sure we were doing good science. But again, 150 million gallons out of a 6 to 7 billion gallon flow system. And we looked at all the biology involved, took 3 to 4 years to do it. So we're comfortable with that number. So that's another alternative to take pressure off of groundwater. So we have looked at those. There are a few other options, but by and large, again, you're going to end up with conservation always being the most cost-effective way to get to where we need to be.
Yes, Pete?
A couple of years ago, I walked up the dry riverbed of the Peace River up to where Kissinger Springs used to be. At the same time, we were dumping water to Tide in the South Florida Water Management District. Is it time that we ought to be talking about maybe doing some inter-district transfers so that we provide water where it's needed and don't waste so much water to Tide?
Conceptually, that makes sense. Logistically, it's pretty rare that you would be in a position where you could really transfer water and have a place to store it sufficiently that you could use it. What you're looking at in the Southwest Florida area where Kissinger Springs no longer flows and the Peace River gets low, the potentiometric surface there is probably still 60 feet lower than it was historically. At one point, it was 100 feet lower than it was historically due to all the phosphate mining and other activities down there. So their options in that area, again, they did the big desal plant. They also built probably by far the largest drinking water reservoir in the state. But the desal plant was probably $250 million. Reservoir was about that same amount of money. So you can do those sorts of things. Again, to try to expand the pie, if you will. But I think your costs for transferring water from, the Kissimmee chain or Lake Okeechobee over to Tampa, your costs are going to be phenomenal. We looked at just getting reuse water from, say, Jacksonville to an area of Keystone Heights where the lakes are low, $300 million just to pump it that far. So that's the problem. It's a cost issue.
Yes.
Right. I'll tell you the best thing we're doing right now is we're building a model that goes all the way, basically covers the entire Florida aquifer. It's the North Florida, Southeast Georgia model, and we are working with Georgia for getting all their data, using their data in the model. We'll share the results of that model or the model itself with parties in Georgia as well. So we're trying to get a better handle on all of that, so we can model the impacts. And it is a little bit disconcerting in that folks from California do think we have a lot more water resources here, and some of them are buying up properties in Southeast Georgia and North Florida, and they're planning on growing some of their crops here in lieu of in California. So the demands on the aquifer for agriculture are going to continue to go up, and again, they have to have not only current best management practices, but kind of like best management practices 2.0. We have to probably take water conservation efforts in agriculture, especially in that region, Suwannee and Southeast Georgia, where ag is the #1 user by far. they're going to have to step up and do, very aggressive water conservation and fertigation efforts.
Follow up then, what are the timelines on these models and how fast before we can put this into policy? Because it seems like we're racing against the clock up here, especially as you were saying, people from California buying huge tracts of land in North Florida, and we're finding out we're doing it for water. So what are the timelines?
Timeline's actually very timely. The NEFSEG model, North Florida Southeast Georgia model, is really being finalized in the next couple of weeks. We're going to be releasing a version of that for the general public and various interested parties to look at. We'll be refining it over time. I think we're briefing our board on it in September, and then try to get a final approval from our board, actually jointly with the Swanee River Water Management District Board in December. So we'll have that tool available to us to help evaluate various impacts.
That'll be released through your website and we can get.
Yes, it'll be noticed on there, absolutely. I'd say August 22nd is our target release date for that.
Anyone else? Good.
Yay!
I've got two myself for Steve, so don't.
Right. You already knew it. That's good.
I may have actually missed this during the presentation, but I thought it was really cool when we were talking about the bio-baling. I had actually never heard of that. But my question was, when you bale it, are you just then taking it off-site to dispose of it? Is somebody using it as biofuel?
Back when the economics of fuels available to electrical power generation were different, when natural gas was more expensive, they were actually burning it at mills. So the examples that we were using, they were hauling it to Jefferson Smurfit, and Smurfit was using it to power their paper mill.
Our experience was the equipment was down 3 times more than it was running, and it ended up being very costly for the operators. We bio-baled up in Salt Springs Island. What was causing the breakdown? Just they can't handle that kind of material. Okay. Yeah, it's set up more for switchgrass and having it take out small oaks.
It,
Not set up for wood.
it works pretty well on Gallberry, but I agree with Carrie that once you switch over to like scrub oaks and whatever, it's gonna struggle more. The interesting thing, and their real niche in the market at that point, was for people who were doing land clearing, because then they didn't have to burn their piles. So from a carbon footprint standpoint, I suppose we could all breathe a little bit better in that they were using it instead of just burning it to consume it. But they were charging about $300 an acre for that service of baling it.
Yes, sir.
My mag on Steve, but some others also, California wanted to take our water and realizing that right now California is buying their blue credits in other states by us creating more saltwater or freshwater marshes. Are we looking at taking some of their dollars or working in some way in that direction to create more wetlands for us?
So one of our board members asked a very similar question of when we're doing these restoration projects, can we capitalize on it as mitigation credit? We could choose to, but then we have to meet the same standards of monitoring that mitigation does. And frankly, that at this point would add cost. We haven't done the cost analysis to say whether it would be worth doing all the monitoring and the pre-work to make it a mitigation bank would be justified by what we'd get for it. But it's sort of like the power generation thing. Maybe not now, but at some point it may actually come back around.
I'd encourage you to look closer into it, having been at the EPA's Blue Carbon workshops that have been held in Florida, Mississippi, and Alabama, and realizing this is a very strong source of funding that we can get onto now to get the dollars. It's something that within itself is going to cover for the monitoring of it and their credits over years versus just a single year purchase.
Okay.
I got a couple for you, Steve. When the modeling was being conducted for the Upper St. Johns Basin with the Corps, were the transpirational losses considered at that time, or that was kind of a after the fact, or? And the second part of that question is, do you see any operational changes in the upper St. Johns Basin based upon the I guess the level of transpirational losses that you're reducing?
So we're still early on. I think we're in year 3 of 5 of validating the transpiration aspects of willow control. And so to make a decision based on what we think is sort of the middle of the term is early. We are we are taking sort of a holistic approach at the Upper Basin project to look at, as it just recently completed as far as the final construction. I've worked for the district for 24 years, and for 20 of those 24, the answer was Three Forks will be done in 3 to 5 years. And it finished. And so now as we've got it done, we're looking at the nuances of, within the flood control responsibility, can we try and do a better job of mimicking the natural hydrology? It's not just about getting the natural lows and the natural highs. It's also what are the averages, what are the timings of those natural lows and natural highs, and there's going to be a degree of conflict between the natural lows and our flood control responsibility. So yes, we are adjusting it, and I think when we have the final reports of what is the transpirational difference, or we actually see it, because we may begin to see it actually in some of the monitoring, then we're going to have to respond to it.
Okay. Any other questions from the audience? Okay, I'm gonna come back to the panel. Y'all have any closing thoughts you want to throw out here now for us?
I think I could speak for most of the panelists. This is, you guys are a great audience. It's a great conference. Appreciate y'all bringing folks together. I was impressed with the degree of science that you all are willing to sit through and respond to. That's great stuff, and I certainly appreciate the opportunity to be here. I think most of us do.
Let's give our panel a round. Thank you. And I think Hitch has some closing remarks for us.
You're on the spot, Hitch. Oh, he's got pictures.
All right. So this may seem just slightly self-serving. This handsome young man who's now 16 years old is my grandson. And that's, his name's Lucas, and he's learning how to drive a car now. And he's got 2 merit badges away from being an Eagle Scout. And he loves to duck hunt. And Rex loves to retrieve his ducks. That's my English Springer Spaniel. And the real reason why I put it up here is because this is the reason why I'm doing this, one of them. I've got 8 grandkids, and I don't know if I'll ever talk any of the granddaughters into going duck hunting after Lucas gave a long dissertation and not very accurate from a factual standpoint on how he killed a water moccasin out in Moccasin Island. But this I thought was a way of showing why I'm here. And, you know, last night we had some conversations on, you know, how long it's going to take to fix these things, especially the root causes, which I think it's pretty apparent to all of us that the root causes need to be addressed just as much as all of the restoration and mitigation efforts. And you're talking about, I'll be long gone. So, and probably some of the younger ones here may be long gone too, but it's all worth it. And it's what the Lord Almighty wants us to do, to take care of his earth. So, and maybe we'll have a few good duck hunts in our future, and so will Lucas and Aria, my other grandson, and my 2 young grandsons that haven't been out with the BB gun yet. So, anyway, thank you very much for coming and staying with us till the end, and we'll be back next year, hopefully.